Good evening, guys. Today we are going to make a video on optimization techniques. So my topic is golden section search using MATLAB or C language. Introduction. So we often hear optimization. So what is meaning of optimization? So the definition is the process of finding the best possible solution to a problem, certain constraints, equality or inequality, or objectives. There are various methods for optimization, such as linear programming, that is, which involves equations that are linear, that which means that are not of the degree of 2 or 3, they are of the degree of linear, that is degree 1, and non-linear programming, which has equations of degree 2 and more than 2, and dynamic programming, etc. These methods involve mathematical techniques to identify optimal solutions or set of solutions. So this is the introduction of optimization. So abstract of our topic, the golden section method. The golden section search is a technique for finding an extreme minimum or maximum of a function inside a specific interval, like a or b, like 1 or 0. In that interval, we are going to find an extreme minimum or maximum of a given function. The method operates by successively narrowing the range of values on the specified intervals, which makes it relatively slow but very robust. In this presentation, we are minimizing an objective function using golden section search by applying several iterations. So iterations are the number of times we are practicing the same method to obtain minimum or maximum point for the given function. So we are here with an example. The example question is, apply 7 iterations of the golden section search to find the minimum of a function given x square divided by 10 minus 2 into sin x, the given interval 0 to 4. In the previous slide, we have seen the interval in which we are going to find the maximum or minimum point to find the optimum value of a function x square by 10 minus 2 sin x. This is the given graph for the above function. So let us go to the solution. Before going solution, we'll see the golden section search algorithm, that how it works. So firstly, we'll start with a search interval x1 and give xu. The statement is given 0 and 4. We'll compute d. So here d is a ratio which is equal to under root 5 minus 1 divided by 2. It is also called as golden ratio, which results in the name golden section search for this method. So let's get back to our algorithm. So now we find x1, capital X1 is equals to x1 plus d, and x2 is equals to xu minus d. See, these x1 and xu are the extreme intervals that we have taken, and we are finding the points between them using x1, capital X1 is equal to small x1 plus d, and x2 is equals to xu minus d, and we find the function values at that point. If the given function value is, if f of x2 is less than f of x1, and the new set of intervals are introduced in our algorithm. This is for first step. If f of x1 is less than f of x2, then x1, the set of x1 x2 is x1 xu is equal to x2 comma xu, and in this way we will find the minimum point. This is the diagram, pictorial representation of the above algorithm. You can pause the video and see the diagram. So I have made an MATLAB program for the above problem. So we have taken here a is the ratio, that is square root of 5 minus 1 by 2. X1 is the point between the two extreme intervals. That low we have taken lower as one side and upper as one side. So k is the first iteration, number of iterations. So we are performing first iteration, so k is equals to 1. y1 and y2 are the function values. This is for display. So for the second iteration, we are performing this loop if else statements. By using if else statement, we are performing the iterations. Here you can see in the second iteration, the extreme left point is becoming the second interval, and the point between these intervals will constitute to the minimum point. So in this way, we are minimizing the interval and finding the minimum or maximum point within those intervals. So this is the tabular form how we find the maximum or minimum optimizer values, and we find the function values. So in the 7 iterations we found this f of x2 and f of x1 values within the intervals. This so here is the graph we have obtained in MATLAB by running the program. Here the blue way the blue color line indicates that it is a minimization problem, and the green color indicates the maximization. That is, if you perform negative operation, it becomes maximum to minimum or minimum to maximum, vice versa. So applications of the golden section search is its simplicity, its robustness, its convergence, and it is flexible, and it is also memory efficient. Other programs are little bit clumsy in memory, but it is memory efficient. So the problem statement, golden section search method to find the maximum area of a triangle inside an ellipse, that is generated by the function x square by 4 plus y square by 9 is equal to 1. So our application on this golden section is to find the maximum area of a triangle inside an ellipse. The equation of an ellipse is x square by 2 plus y square by 9 is equal to 1. Here is the picture. So for this I have used C language. You can see the code. I have performed this code in Visual Studio Code. So I made a function called golden section search max. So in this we are maximizing, not minimizing. We are maximizing the area of a triangle inside an ellipse using golden section search. So you can see the code here, similar to what I have explained for C code MATLAB. It is somewhat similar to it. So the given triangular area return value we are using in the main function to obtain the results. So for this I have used some online resources like Stack Overflow, and I have taken the help of ChatGPT also. So in this way I have made a program on golden section search using